Now, today in this video lecture, we are going to discuss diffusion, types of diffusion, fix first law, second law, factors affecting diffusion. See, what is diffusion? Diffusion, in a simple word, we can say migration of the atom from one place to the other place in a crystal lattice. So actually, it takes place because of the thermal energy which is absorbed by the atoms. When the atoms absorb the thermal energy, they vibrate about their mean position and they get migrated to the new position. So it is known as diffusion. The gradient can be the concentration gradient in a diffusion. So diffusion takes place in all the three states, that is solid, liquid and gas ions. So benefits of diffusion: it helps to control the properties of the material. They play important role in many solid state phenomena and in kinetics of microstructural changes during metallurgical processing and applications. Example: phase transformation in metals or alloys, carburization, case hardening of the steel, oxidation of metals, improving corrosion resistance, metal cladding, brazing, etc. Now diffusion mechanisms: vacancy diffusion and interstitial diffusion. Now you see this diagram. This is the original position of the atom. So this position is vacant. So this atom get migrated to this new position. This atom get migrated to this new position, and see, this is the new position occupied by the migrated atoms. Okay, and interstitial diffusion means in atoms the interstitial positions move from their original position to the neighboring interstitial positions. Okay, this mechanism occur at a faster rate than vacancy mechanism. Now Fick's law. So this is also known as steady state diffusion. Steady state diffusion is the process in which net number of atoms passing through a unit area perpendicular to the diffusion direction per unit time is constant. See, it means you consider the unit area. So the number of atoms passing through that unit area per unit time means per second. Okay, so every time the rate will be constant. For example, at this instant 10 atoms are diffusing per second. So in the next second 10 atoms will be diffused. Okay, and number of atoms passing through unit area perpendicular to it and per unit time, it is known as diffusion flux. So diffusion flux is directly proportional to dc by dx. dc means concentration gradient, dx means change in the distance, j means diffusion flux. It is expressed as atoms per meter cube second. dc by dx concentration gradient, atoms per meter cube meter. C means volume concentration of the atom, means atoms per meter cube. X means distance between the planes in the direction of flow of the atoms, and capital D is the constant. It is known as diffusion coefficient of diffusivity. So here negative sign is introduced because during the start or at the start of the diffusion concentration is more, and as the time passes, as the time elapses, the concentration decreases, and therefore negative sign is introduced in this equation. So concentration gradient dc by dx, it is nothing but Ca minus Cb divided by Xa minus Xb. You see this figure. So these are the atoms, these are diffusing through this unit area which is perpendicular and in unit time. So you see here A, at the point A, Ca is the concentration, at the point B, Cb is the concentration. So initially Ca is greater than Cb, and Xa means this is the initial distance, and Xb means this is the distance after the diffusion. So this is the first law. So in the VTO this question is important. This question may be asked. State and explain Fick's first law of diffusion. Now Fick's second law of diffusion. So it is expressed, see, it is also known as state or dynamic state diffusion. The diffusion flux J and concentration gradient dc by dx at some particular point in a solid vary with time. So in the last law I told you, every time the number of atoms diffusing per unit time, that rate is constant, but here the rate varies. For example, at the instant 10 atoms are diffusing, in the next instant maybe 20 atoms diffusing, next maybe 30 atoms diffusing, maybe 5 atoms diffusing. That means the diffusion rate changes. So it states that the rate of accumulation of diffusing material, rate of accumulation of diffusing material means dc by dx, it is equal to diffusivity means d into concentration gradient. D means diffusivity into d square c divided by dx square means concentration gradient. Okay, so dc by dx rate of accumulation of diffusing material atoms per meter cube second, dc by dx concentration gradient atoms per meter cube meter, c means volume concentration of atoms, it is expressed as atoms per meter cube, x means distance between the planes in the direction of flow of the atom, d means diffusivity, already I told you, it is expressed as meter cube per second. Okay, so mathematically, okay, it is given by cs minus cx divided by cs minus co is equal to erf x divided by 2 under root dt. erf means Gaussian error function. So what is d here? D means diffusivity of atoms. cs means a constant which denotes the concentration of diffusing. CO means a concentration of atoms at the start of the processing when the time is 0. Cx means concentration at some distance x from the source of diffusing atoms at time t. And ERF means it is a special function called as Gaussian error function. See, it is a non-steady state and therefore see the graph is a curved line. It is not a straight line. Okay, so along the y-axis we consider concentration C and along the x-axis we consider x. Okay, now factors affecting diffusion. As the temperature increases, diffusivity also increases or flux of atoms also increases. It is given by the mathematical equation d is equal to d0 into e raised to minus q divided by RT. Crystal structure. Crystal structure with more imperfection allow diffusion to take place at a faster rate. See, as the crystal is more imperfect, diffusion rate will be more. Okay, APF, that means atomic packing factor. APF, crystals with high APF, they possess low diffusivity and vice versa. Atomic radius, smaller is the atomic radius, higher will be the diffusion. Concentration gradient, when the concentration gradient is higher, the rate of diffusion or diffusivity will also be more. Thank you. This completes first half part of module number 1.